Okay, so we're going to be looking at tangents. So a tangent, I may have heard somebody go off on a tangent before. A tangent is a line that intersects a circle just at one point. Just at that one point. So here, if a line is drawn tangent to a circle, so here's the line, it only intersects the circle at exactly one point, then it's tangent. Because of that, it's going to be perpendicular to the radius. And also, if we have a line that's perpendicular to the radius at the end point of the circle, it must be a tangent. So just a different way of rewriting it. But most of the time, we're going to say, hey, this is a tangent. Now, if we have two segments from the same exterior point, so they intersect out here, and they're tangent to the circle, then they are congruent. So that means AB is equal to AC. So if we have two tangent lines that intersect outside the circle, those two segment lengths will be congruent. And those are important for questions like this. So if I have here, I want to solve for x, well, look at this first one. Assume all lines are tangents that appear to be, right? So these two lines are tangent lines. So that means that the two lengths are equal. So 2x minus 5 equals x plus 5. So x equals 10. Done. Same with number 2. 2x minus 13 equals x minus 1. So I get x is equal to 12. Over here, there's a lot of extra stuff going on here. I don't need to know about that or care about that because I have these two tangent lines. So 2x minus 4 equals x plus 3. So x equals 7. Then over here, 2x minus 16 equals negative 5 plus x. So x is equal to 11. Now, for some of these problems, we get a little bit more challenging. But here we just have a big rectangle. We don't know if it's a square, but we can say that because these two distances are the same and these two distances are the same, it must be a square, so x is equal to 19. So not really any steps to write out there, just some logic to think through. Here, because this is a tangent and that's a radius, we know that's a 90-degree angle, so we can use Pythagorean theorem, and we can say 15 squared plus 20 squared equals x squared. So 15 squared is going to be 225, so we get 225 plus 400 is equal to x squared. So that's 625 is equal to x squared. So we can just take the square root of that, so 625 square root of that is 25. Here, simply again, we can say that x is equal to 12. All right, now here we have a tangent, and here we have a chord. So we have to be careful with this one. We can't say that x is equal to 40 because that just simply is not true. But what we could do is we could draw this line here and give ourselves a nice little right triangle. We know that this is going to be 30. So what we could say is 40 squared, right, this leg, plus 30 squared equals x plus 30 squared. Give ourselves a nice little quadratic. So this is going to be 40 squared, which is 1600, plus 900 is equal to, this we multiply out, so we get x squared plus 30x, which is 60x, plus 900. So actually the 900s cancel out. Because this is quadratic, I want to set it equal to 0. So 0 is equal to x squared plus 60x minus 1600. 0 is equal to, and then we factor this. So we want x and x, and then we want two factors of 1600 that are 60 apart from each other. Well, sometimes it helps to think about 6 and factors of 16. So 16 well, there's a bunch of different factors in there, right? So sometimes it may actually help. If you have a graphing calculator, you can actually graph it. So this one is a little bit more involved than some of our other problems we've had before. So I'm just working out the different factors here. All right, well, 1600. So 1 1600 to 800. So 1600 divided by 4 and 400. 1600 divided by 10. Now 1600 divided by 100. Now 1600 divided by 20. There you go. 1600 divided by 20 is 80. I need some coffee. So we get these two answers. So we get x this is going to be x plus 80. So we get x is equal to 20 and x is equal to negative 80. Well, we can't have a negative 80 distance, so x is 20. This is extraneous. So a little bit more algebra with that one. Don't forget the geometry piece, though. So here, for this one, we can see that we have, yet again, we're going to have this right triangle in there. Well, this is 21. Don't forget that this is also the radius. That's 21. So this whole hypotenuse is going to be 29. So we can say that we have x squared plus 21 squared equals 29 squared. So we get x squared plus 21 squared is 441 plus 29 squared is going to be 841. So we get x squared is equal to 400. So x is going to be equal to 20. And then down here for this problem, we need to do, if this is 5, this is 5. Radius is perpendicular to the tangent. So we get x squared plus 25 is equal to, because this is 5 as well, this whole distance is 13, right? So 13 squared. Whoops. I'll just write out the theorem. So x squared plus 5 squared equals 13 squared. So we get x squared plus 25 equals 169. So x is equal to 12 because x squared is equal to 144. All right, so with this, make sure you understand the problems. If you're looking at questions like 4 and 5 and 6 and you're struggling, especially with 4, that's more advanced algebra. But all we're doing is we're taking our old concepts of Pythagorean theorem and introducing it to these ideas that tangents are perpendicular to radii and diameters, and that the tangent distance is equidistant outside of a circle. So understand the vocabulary, the terms, and don't forget, keep reviewing your algebra.